This conference will now be recorded.
Good morning, students. So yesterday we were talking about this method, right? So here, what we were talking that suppose some river is there, right? So within this river, if we will observe that, so we were talking actually the method, analytical method. Within analytical method, we have three methods. If you will, we will observe here. That is also here available. So within analytical method, if we will observe, there are the three methods: water budget method, energy balance method, and mass transfer method. We will see this is more important method actually. So we will see this water budget method. So here, what is that actually? See here, this equation is given. This equation is nothing but whatever we are looking here is same almost. There is nothing difference. So here it will be very clear to understand this. See, suppose this is the river, right? This is the river. Within this river, some precipitation is occurring. Here, some precipitation. This is precipitation. Now, what will happen when precipitation will occur? Then some surface inflow will come here, right? And this surface inflow means because of runoff, maybe, right? And because of runoff, somewhat infiltration will be there, and due to this infiltration, some water will come in through water table into the river. So that is called as, this is surface inflow, this is groundwater inflow. And what is the another source? That is the precipitation, right? So here you will see this is the inflow. Now what will happen once this water will come into the river, at the same time some amount of water will be used for the crop purpose or for the hydropower project or any other purposes. So that is what this is surface outflow, means this is the use of water. Then some amount of water is going loss, that is called as ground outflow, means that is seepage loss, right? Now see, some amount of water is coming, some amount of water is going outside, so means there is some change in storage. So this is what, this depth we will say this is change in storage, so that's why delta S. And see, we have to find, see, some quantity of water is incoming, some quantity of water is going out. So ultimately we have to find one equation, and within that equation there will be the one loss, that is the evaporation loss is also there, because some amount of water is going out into the atmosphere, that is called as evaporation loss, right? And some amount of water is also there, like on the tree suppose, and some amount of water is over the tree, and that will also go into the atmosphere. So in some equations, some of the scientists, they include that one also, right? So here, if you will see that, that is, this is also included, that is TL. TL means transpiration loss, daily transmission loss. Some equation they include, some and some maybe not include. So here, just to understand this equation, what is that? Whatever the incoming is there. So here, inflow, right, minus outflow will be equal to change in the storage. Storage. Change in the storage means, suppose 10 meter cube of water is meter cube per second water came, and the outflow is say 8 meter cube water, meter cube per second is there. So 2 meter cube per second is what, that is the change in storage, or that is we can say remaining. Or the another example is, suppose we have the 10 real Omani real, right, that is incoming daily income for example, and 8 Omani real is going out. So how much is remaining? 2 Omani real is remaining. The same thing is here, right? So here you will see the surface inflow, this is inflow, surface inflow now. those who are coming, so we will take it as a inflow, right? So here surface inflow minus, we'll see this, whatever incoming is there minus, if we'll deduct the outflow, that we will get the, this should be plus actually, I think, right? Surface inflow plus ground inflow, because this inflow is coming, so that's why these are plus. That is ground inflow plus P is what? Precipitation, this rainfall, minus which is going outside means what? This SOF, so minus SOF, and again which is going outside, this is GOF is also going outside, that's why here it is also out, because this is minus and this plus means nothing but minus, minus plus minus, right? If you will see this, that's why I have taken in the bracket, so whatever I have taken it is in plus, when it will come outside it will become minus. So here this GOF is nothing but this is seepage loss, right? This is going out, then other SOF is going out, and then what is going out? Evaporation is also there, and we can also add TL. TL means transpiration loss, we can also add. When we will take the difference, then we will get delta S, that is the change in the storage. I hope this is clear. This will be clear, this equation will be clear now. After that, one numerical is given and we have to find the, based on that equation, we have to find the evaporation loss, right? So here I should just take outside. That will be more clear to you, right? I will read the problem and then we will solve this problem, right? So here, see, the question is given that the average surface area of the reservoir in a month of June, is 20 kilometer square, means what they are saying that one reservoir means some water body is there and its area is say 20 kilometer square in the month of June. So in the same month, the average rate of flow is 10 meter cube per second, right? Average rate of inflow, that should be inflow. Average rate of inflow is, means some quantity of water is coming, which is what? 10 meter cube per second is incoming in the river. Outflow rate is 15 meter cube per second. Some amount of water is going out, that is what? 15 meter cube per second. Monthly rainfall is 10 centimeter. So monthly rainfall is also coming. This rainfall is how much? That is 10 centimeter rainfall is also incoming. And what is saying? And monthly seepage loss means some amount of water is also going. That is what? 1.8 centimeter. And the change in the storage means some amount of water is incoming, some amount of water is going out, right? It is as simple, suppose this is your river, some amount of water is incoming, some amount of water is going out. Suppose whatever the incoming is there, if incoming is less, means suppose this is 1 and outgoing is 2, it means we are in loss, because suppose we have 1 Omani Rial in my pocket and 2 Omani Rial I have to give to someone, means I will take 1 Omani Rial from some person and then I will give, means 1 Omani Rial is loss. It means I will say this loss is now, or we can say this change in storage, or this change is what? That is negative. So what he is saying, the change storage is 16 meter cube per second, means this incoming and outgoing, if I will see the difference. So this change in storage, that is delta S, is 16 million meter cube. So here it will be minus. It depends on how much quantity of water is incoming and outgoing. So here simply we can see this incoming is less and outgoing is more, right? That's why I have taken this delta S is as a negative, right? Now, find the evaporation loss in that month in centimeter. So here we have to find the how much amount of water evaporation loss will be there. So we know that the equation, our basic equation is inflow minus outflow, right? Minus outflow is equal to change in storage, right? This is basic equation. Sorry, this is our basic equation, right? Now we know that what is inflow. This is inflow 1, 2, right? And outflow is how much? This one 15 meter cube and 1.8 centimeter. And this area is given, right? And evaporation is also outgoing, but we don't know. We have to find what is that. So here, so first of all, we will do one thing. All given data we will write and we will convert this into one unit. Because see, if you will see here, this is given in meter cube per second incoming, and this is given in depth. Means they are two different units. Similarly, outflow is also given in meter cube per second and in depth also. So either we will convert this into in depth, means in either in depth, or we can convert it into volume. How much quantity of water is volume is incoming and outgoing, or so which one will be more? I think volume is more important. So whatever quantity is given, we will convert all into volume, right? So first of all, I will write surface inflow. There are two things, inflow and outflow. I will say first surface inflow, right? And another term I will take it as outflow, right? So here I will take two column, that is surface outflow. Surface inflow is there and surface outflow, right? Now whatever the surface inflow is there, first inflow is given as 10 meter cube per second. That is, I will say surface inflow, SIF, surface inflow, that is given 10 meter cube per second. So now this is given in volumetric. We have to convert it into in terms of depth. So here we know that this is in 1 second, right? This 10 meter cube per second is in 1 second, right? This is in unit, single unit time. And this inflow is for which month? June month. And we know the month of June is of 30 days, right? Now, volume will be what? Volume means in whole month, how much quantity of water will be lost? So this 10 meter cube per second in 1 second means if I will multiply it by 60, I will get in 1 minute. If again I will multiply it by 60, I will get in 1 hour. If again I will multiply it by 24, means I will get in 1 day. And again, if I will multiply it by 30, I will get in for whole month, because here this month is of 30 days, right? So here if I will calculate, I will get the value is 2592000 and meter cube. Now here if I will convert this, it will come 25.92 million meter cube. Similarly, there is one more, that is rainfall, right? This is my first in parameter. The second is rainfall. Rainfall means p value. How much this p value is here, right? So we know that rainfall is 10 centimeter depth. And we know the area. So if I will multiply the area of reservoir, I will get the quantity in volume, right? Reservoir. So reservoir area is given as a 20 kilometer square. Now I have to convert this into meter square. So what I will do, and here this 10 centimeter is in centimeter. So this is 10 centimeter. I will convert this one also in meter and this one also in meter square, so that I will get in meter cube, right? So here 10 centimeter means 0.1 meter multiplied by this 20 kilometer square means 20 into 10 to the power 6 meter square, right? Meter square. So when I will multiply both, then I will get in meter cube, and what would be the quantity? That will be 2 into 10 to the power 6 meter cube. Now, if I will convert this into million meter cube, what I will do simply, this 1 million means how much? 10 to the power 6, right? So here, if I will replace by, it will be 2 and million meter cube. We know that this 1 million means 10 to the power 6, right? So here this is 2 million meter cube is the rainfall for the whole area. This is the quantity of water which is incoming by rainfall, right? So we know that there are the two quantities. First is this one inflow, and second one is this 2 million meter cube, right? This one. Now, what is outflow? Surface outflow is also there. So surface outflow is first is 15 meter cube is given per second, and this is what's that is surface OF, surface outflow, right? I have to convert it into this volume. So 15 meter cube per second. If I will multiply by 60, it will be in 1 minute. Again, I will multiply it 60, it will be in 1 hour. If I will multiply it by 24, it will be in 1 day, and again 30 multiplied by 30, it is in 1 month, right? So here it will come 38880000 meter cube directly. So if you will convert it, it will come 38.88 million meter cube. Just you can convert now. Now another is the seepage loss. Seepage loss. Seepage loss means what? That is, we can say ground outflow, right? Ground outflow is the seepage loss. And when I will convert this ground outflow into volumetric, GOF, right? Seepage loss means which is going through the ground. So I will say GOF is what? Seepage loss, and that is what given as a 1.8 centimeter, right? 1.8 centimeter is given. Yes, 1.8 centimeter is given in the problem. So simply I will convert this 1.8 centimeter into volumetric. So what I know, 1.8 divided by 100, I will get into meter. Now if I will multiply the area of reservoir, so I will get it's million meter cube. I mean I will get in volume. It will be 1.8 into 10 to the power minus 2 into area is given as 20 into 10 to the power 6. I will directly put the value. So here I will get 36,000, 36 and again 40 meter cube, right? Now if I will convert it, if I will divide it by 10 to the power 6, so directly it will be converted into million meter cube, right? So here it will become 0.36 million meter cube, right? Now we know that the inflow minus outflow is what? That is our change in storage. And change in storage. So first I will write my equation, that is surface inflow plus ground water inflow plus rainfall is equal minus of outflow. This is inflow, right? This is inflow. This is outflow plus evaporation loss is equal to change in storage, right? So change in storage is minus because the incoming quantity is less and outgoing quantity is more. So that's why I'm taking it as a minus. And it is given as 16 million meter cube. I will put here surface inflow, that is given, we taken it as a, we actually we determined 25.92 plus this 2, right? And if what is the, so this is 2 quantity right now plus only 2 quantities then. SOF is 38 and GOF is 0.36. So directly here only 2 quantities given. So here I can say that this surface inflow minus surface outflow minus surface outflow. Outflow is how much? First we got this 38.88 million meter cube plus 0.36, that is our ground outflow, plus evaporation loss EL is equal to minus change in storage, right? Now when I will solve this, it will become 25.92 plus 2, that is 27.92 minus, if I will solve this, I will get it, so whatever it is, 38.88 plus 0.36, so just I will write minus 38.88 minus 0.36 minus EL is equal to minus 16. Now when I will solve it, I will get EL will be equal to, just you have to do the plus and minus only, right? So you will get this EL will be equal to 4.68 million meter cube, right? Now, what is given in the question, what he is asking that you find the evaporation loss in month in centimeter, right? If you will see this, this is find in centimeter, means we have to convert it into this million meter cube into centimeter, right? So simply we know the volume, we know that volume is equal to what? Area depth, right? So we have to find in terms of depth. So depth will be equal to what? Depth will be equal to volume divided by area. So here depth, depth we don't know, right? That is what depth means, depth of evaporation in centimeter. Now here volume is, we got 4.68 million meter cube. So if I will convert it again into meter cube, so I will multiply by 10 to the power 6. Then this volume will be converted into meter cube, then divided by area. Area means 20 kilometer square is given, so 20 into, if I will convert into this kilometer square into meter square, what I will do? Multiply by 10 to the power 6, right? So here this will be cancelled, and when I will solve, then I will get the depth of evaporation loss EL, right, is equal to 0.234 meter. When I will multiply 0.234 by 100, I will get in centimeter, and that will come 23.4 centimeter. That is the answer, right? I hope this question will be clear to you. So the same, this solution is same. Here it is given, and we got this solution, right? This is our solution. I hope this question will be clear. Now next is, next equation is what? See, this is a water budget method, and we have seen one numerical on this, right? Water budget. See, in our equation, this equation and this equation is both are same, right? if you will see this equation, both are same. But here I have not included the transpiration loss. So you can do one thing. You can add here the plus transpiration loss means TL. So if transpiration loss is given, then you can also include, and everything will be same. Right? So here this is the equation. The same, this is the same. Now there is another equation, that is the energy budget method. That is also the energy budget method is the application of the law of conservation of energy. See, whatever the energy available for the operation is determined by considering the incoming energy, outgoing energy, and the energy, the same thing, but it is in terms of energy, right? And in the previous one, in terms of, that is the, in terms of, we have taken as a inflow and minus outflow, that is the in terms of mass. So here whatever the inflow energy minus outflow energy is equal to remaining is or stored energy. They have, this is the principle, right? Stored energy. This is same as we have seen here above in the previous method. Here this Hn, that is Hn is equal to what? The net heat energy received by some water surface is equal to what? So this is equal to what? Ha plus He plus Hg plus Hs plus Hi, right? And here just you remember this equation, right? This is what? This is the energy budget method. So maybe like some energies will be given and we have to find that what is the net energy, right? Next method is see here some what are the HB, HA, HE, HG, HS, HI, everything is given. HB is what? Back radiation from water body. Suppose this is our water body, right? So some of the energy is coming, some of the energy is going out, some of the energy is absorbed by the water body, right? So every detail is given for energy budget method. But is the simple basic rule is what? Whatever the incoming energy is here. So here you will see that some of the radiation is coming, right? So some of the radiation, solar radiation is coming. Some of radiation is going inside. That is what? 1 minus R into Hc. Some of the energy in going out, that is reflect. We can say reflected, right? So these all are given and their notations are given. And what is that? We know this. So Hc means solar radiation. Back radiation means Hb. Reflected means what? This back and reflected means it is reflecting is something little difference is there. Reflected means it is coming in the atmosphere, and this back means it is again going there, right? Then Ha means what? Heat loss due to the air, and this is some of the loss of water body. From water body is evaporation, right? Some of the energy is absorbed, that is heat absorbed, that is Hs, right? And Hg is what? Heat flux into the ground. Some of the heat is going into the ground, some of the heat is going into the this water. And whatever the energy we want to calculate the evaporation loss. So the simple is what? The whatever the energy is coming, whatever going is out, is equal to the change in the storage. The same thing is given here. Now again, see again this how this different parameters are calculated is given here. How this evaporation loss finally we will calculate, that is Hn minus Hg minus Hs minus Hi upon rho into L 1 plus beta. And what is beta? Beta is equal to this HA divided by rho this into L into EL, and what multiplied by this. So again these values are given for different components. So we can finally apply this formula, these two formula. First is this formula, and for getting this beta value we will apply this formula. Then we will get beta value, then other values will be given, and L and rho is that will be also given. Means every parameter will be given, and we will find the evaporation loss by the energy budget method. That mass transfer method. Mass transfer method is based on theory of turbulent mass transfer in the boundary layer to calculate the mass water vapor transfer from surface to surrounding atmosphere. Suppose this is one water body, some of the mass will be transferred to the this in the form of evaporation, and here it will be in the atmosphere. So here this is actually just what we can say. It is only theoretical method, we can say. Not details are given here. Now next term is, see, first was we have taken the method is the this through some analytical and method. The next is evaporimeter. Evaporimeter or measurement of operation by some instruments are here. So here first instrument named is as a lesimeter. Next is field plots, right? Another is Feynman's equation is also there to find out this. We will see it one by one. So here in your presentation, so see, we have seen this analytical method. So within that method, there are the three methods, right? Water budget, energy balance, and mass transfer method. These are what? These are analytical method of operation. Now another is there. That is evaporimeter. Evaporimeter means some instrument is there, and through that instrument we find the evaporation loss, right? So here we will see this method later. What is evaporimeter? See what I told you that in the earlier. Suppose there is a lake, right? And I kept also one pan here. So whatever the evaporation will be from this lake, that is evaporation loss EL, and whatever the evaporation will be from the pan, these both will be very different, right? The evaporation loss in the pan will be more than the evaporation loss in the lake, right? So what we do, we consider that this pan nearby the lake represents the evaporation from the lake, right? But obviously they are not similar, so we know that this is not similar. So we have introduced one coefficient that is called as pan coefficient. So here we take this formula as a lake evaporation is equal to, we take it as a, so first is evaporimeter, that is the pan evaporation. We are taking first from pan, right? So here we have taken as a one lake is there and one pan nearby the lake is there. So whatever the evaporation loss will be here, that will be very, we can say more than the evaporation loss through the lake, right? So here in this case, the formula is lake evaporation is equal to pan evaporation, but it is multiplied by with some pan coefficient, multiplied by pan coefficient, and this pan coefficient is some value, and this value is from 0 to 1, in between 0 to 1, right? So when we not 0 to 1, we sorry, we can say this is from 0.7 to 0.8, right? From 0.7 to 0.8, and it will be always greater than 0 and less than 1. So it will be always, we can say, less than 1, right? And it will, and here the range is already given this for the pan evaporation. Again, there are the different types of pan is of different types, right? ISI mean Indian standard pan is there. Some other pans are also there. We are not going into that detail, but there are the different types of pans, right? Types of pan are also there. Now, once pan is clear to you, now we will see one problem over the pan. You remember this formula, just lake evaporation is equal to pan evaporation multiplied by pan coefficient, right? This one. This formula is very important. Now, the problem is given as at the beginning of the certain month, I'm taking this problem from here and we will solve in this. Here we will solve this problem. Now, at the beginning of certain month, the depth, just wait, I will, battery is low. Now, I will read this problem again. Now, what problem is saying, at the beginning of certain month, the depth of water in an evaporation, one point, an evaporation, the depth of, see, something is wrong. At the beginning of the certain month, the depth of water in an the depth of water of an evaporation, actually of an evaporation, the depth of water of in evaporation, correct? No, at the beginning of certain month, the depth of water in a evaporation and 1.2 meter diameter pan, this is 1.2 meter diameter pan, was 7.75 centimeter. Means one pan is there. If you will see, this pan is there, and its diameter is as a 1.2 meter, right? And within that depth, within that pan, the depth of water was how much? 7.75 centimeter, right? Then what is saying, during the month, means in 1 month, the rainfall was 3.8 centimeter, and 2.5 centimeter of water was removed from the pan to keep the depth of water in it within a fixed range. Like there was a pan, right? Within that pan, some depth of water was there, right? What happened? One rainfall occurred. So rainfall occurred, then what will happen? Then it is filled with water. So what they did, see this, the rainfall was 3.8 centimeter. Means after 3.8 centimeter rainfall, this depth was maintained, right? And what they are saying, they reduced the water from that pan 2.5 centimeters so that this should not overflow, right? So to maintain that water, so they removed 2.5 centimeter depth of water. They removed this water through this pan. At the end of the month, the gauge indicate a depth of 8.32 centimeter of water in the pan. So after the month end, the depth of water shows that it is 8.32 centimeter, right? So here, if you will see that this initially this depth was 7.75 centimeter, then it after the rainfall of 3.8 centimeter. So here, how much will be total? 9.05 centimeter, right? What he's saying, they also removed the 2.5 centimeter. They removed the 2.5 centimeter water from that pan. So here, if you will see that whatever the depth, and again, if this total is how much? 9.05 centimeter. So from 9.05 centimeter, some amount of depth of water like this is how much? 2.5 is removed. Means what? 9.05 centimeter minus 2.5 centimeter. That will be the remaining one, right? So here, how much remaining is? That is 8.32. 8.32 centimeter will be the answer. That is remaining one. Now what he's saying, the pan coefficient is 0.7. This pan coefficient is 0.7, right? So if you will see, this pan coefficient is generally denoted by CP, pan coefficient, CP, pan coefficient sometimes, right? CP, we have seen already in our presentation. I will show you after this numerical. Now, estimate the evaporation during the month. So we have to find what would be the evaporation loss. EL will be what? So again, this method is based on water budget method, right? Water budget method. And water budget method is what? Whatever the inflow minus outflow, it is some kind of like that, right? So we will do that is change in storage, and then once we know the evaporation from lake and evaporation from pan, right? And we will multiply by the pan coefficient, then we will get the loss of water or evaporation loss from the lake. So simply what we will do, we know that, okay, so this is our pan, right? Or that is better, previous one was better. That is already clear to you, I think. This is pan. From the pan, initially it was 7.75 centimeter. Then rainfall occurred. So here it became 3.8 centimeter rainfall occurred. So total become 9. How much? 0.5 centimeter. Then after what happened? They removed some quantity of water. That quantity of water was 2.5 centimeter. So here, yes, they removed 2.5 centimeter. They got, so how much it is total remaining is how much from year to year? 8.32 centimeter. Am I right? 7.5 plus 3.8 is 9. 7.75 plus 3.8 is how much? Sorry, 7.75 plus 3.8. 11.3. We'll check once again. Just again, I will check. Is there any law? 7.75 plus 3.8 minus 2.5. Okay. So here, no. This is how much? This is 11 point something, right? 11.55 centimeter, right? Then I will remove this 2.5 centimeter. It will become 9.05 centimeter, right? So it will become 9.5 centimeter, right? So this 9.5 centimeter, 9.05 centimeter, right? 9.05 centimeter will be remaining. And that is what? That is the net depth of water in the pan, right? Now, this is net depth of water in the pan. Then what happens? See, depth of water in the pan at the end of month. What he's saying in the question, at the end of the month, they are saying that the gauge indicates the depth of water is 8.32 centimeter, right? Means, see, after 1 day, 2 day, 3 day, 4 day, likewise, after 30 days or at the end of the month, this depth shows that this remaining water is 8.32 centimeter, right? It means what? The depth of water which is evaporated is how much? See, initially, I think you got my point. So this, the total was 9.05 centimeter, but at the end of the month, they noted that this is 8.32. Means 9.05 centimeter minus 8.32 centimeter. So I will get the evaporated water or evaporation from pan, right? It will be how much? It will be 0.73 centimeter. Now we know that the lake evaporation is equal to pan evaporation multiplied by pan coefficient, that is Cp. So pan 3 centimeter multiplied by pan coefficient is 0.7. So we will get the answer is how much? 0.511 centimeter. If I will multiply it by 0.511 into 10, I will get into mm. So that will be what? 5.11 mm. So this is what in mm answer. So I hope this is question is clear to you. This is the answer, right? There is another problem. We will see this on also. See, all these problems are based on water budget method and the combination of this. So here, I will just copy this problem. I will read the problem and we will solve immediately. The area of the reservoir is 1 kilometer square. There is saying that some reservoir is there and its area is 1 kilometer square, right? The water level in the reservoir is observed, it is observed, right? This word is observed. Observed to decline by 20 centimeter. Means there is this water body is there, and within that water body, suppose water is up to, oh, this is filled with whole water, right? What is saying that the reservoir declined by 20 centimeter, means suppose I don't know the total depth, right? This is 20 centimeter is decline, right? By evaporation in certain period, right? The reservoir receives the rainfall inflow is 10 hectare. Now this rainfall, that P is given as 10 hectare. Now some unit is different, right? We know that, see, you should know that 1 hectare meter is equal to how much? 10 to the power 4 meter square, right? Now 10 to the power 4 meter. Just I'll Yes, 10 to the power 4, we can say meter square. Anyway, you remember this. So what is saying that the reservoir receives the surface inflow is 10 hectare and outflow is 20 hectare. Means this is inflow. What is something is saying that outflow is also there. That is how much? That outflow is 20 hectare, right? Are of 20 hectare are abstracted from the reservoir for irrigation, right? And electric power generation means this much quantity of water used for the electric generation and for the irrigation purpose. The pan evaporation and rainfall recorded during the same period is 12 centimeter and 3 centimeter respectively. The pan evaporation is 12 centimeter, and what is saying rainfall, that P is recorded as 3 centimeter. The pan coefficient is also given, that Cp is given as 0.7. Determine the Cp loss during this period in hectare meter. So what we will do first, we will write the given data, right? Here one thing is that area is given as 1 kilometer square for this reservoir, right? This area is given. Now next is what? That change in storage is given. That is what is saying, that change in storage is 20 centimeter, right? I want now, just I will write 20 centimeter. I don't know whether it is plus or minus, because when it will be minus, when incoming is small and outgoing is more, then this change in storage will be minus. But when it is more, this is more, and outgoing is less, then we will use this delta S is plus, right? So here just I don't know. Now after that, what is saying? Surface inflow, SIF, surface inflow is 10 hectare meter, and what is saying, surface outflow is also given. Surface outflow is given as 20 hectare meter. Means now we can, now here it is clear. It means which is going out is more and incoming is less. So here a delta storage is what? Minus. So here I will use as a minus. Now after that, what is given? Pan coefficient Cp is given as 0.7. Rainfall is given 3 centimeter, and reservoir evaporation, we can say, that is also given. Reservoir evaporation of reservoir loss, reservoir evaporation, that is given as what? 12 centimeter. So 12 centimeter means what? So here just I will write 12 centimeter. And we know that lake evaporation is equal to pan coefficient multiplied by pan evaporation, right? So through this I can get this reservoir operation, that is pan coefficient is 0.7 multiplied by pan, that is what? Lake evaporation is equal to pan evaporation multiplied by pan evaporation. So here 12 centimeter is what? The pan evaporation is 12 centimeter, right? This is not reservoir. Pan evaporation is given. So pan evaporation 12 multiplied by pan coefficient, we will get the reservoir lake evaporation. So we will get it as a 12.4, 8.4 centimeter. Now we will do one thing. We have written all the given data. We will arrange into proper manner, like what is that? That is inflow and outflow, right? And then we will solve it. So inflow is inflow, this is surface inflow, this is outflow. So inflow is what? That is 10 hectare meter. Now we will do one thing. All we will convert it into one unit. Suppose this is a what? This is hectare meter. So we will convert all these things into hectare meter. So how? See, rainfall is given as 3 centimeter. So what I will do, if this rainfall is 3 centimeter multiplied by, that is what? That is the area. Area is what? Area is in kilometer square multiplied by 3 centimeter. So this 3 centimeter, if I will multiply it or divide by 100, so it will be what? That is 10 to the power minus 2 meter into area is what? 1 kilometer square. So here I will put 1 and into 10 to the power 6, it will be in meter square. So here I will get rainfall in depths. So here just you remember, or we can do one thing. We can do one thing. That is what? This is 10 to the power minus 2, 3 centimeter, and this 3 centimeter is 10 to the power minus 2 meter. So this meter and this meter square is there. Or directly what I can do. So here if I will solve, it will become what? 3 into 10 to the power 4. Now this meter is square and this meter, it will be what? Meter cube. And I know that this 10 to the power 4 is what? 1 hectare. So here this, it will be converted into hectare. What will be remaining? See, we know that 10 to the power 4 meter square is equal to 1 hectare. So here directly what I will do? I will write it 3, and this 3 and this 10 to the power 4 is what? Hectare. So what is remaining? 1 meter is remaining, because here you know that this 3 meter, this is meter cube and this is meter square. 1 meter is remaining, so hectare and meter. So simply this is hectare meter. Right now, there, that is inflow. What is outflow? Outflow is what? Surface outflow is 20 hectare meter. That is given. Now next is evaporation is given. And that is also a outflow. If water is going out into the atmosphere, means that is loss. That is outflow. That is given as how much? We have just calculated 8.4 centimeter. So I will convert it again. 8.4 multiplied by 10 to the power minus 2. It will be in meter into what is area is 10 to the power 6. That is meter square. Right. So directly I can write it into this. If I will solve, it will become to 8.4 into 10 to the power 4 meter cube. So directly I can write 8.4, and this is what? Hectare. Hectare. And this one remaining is 1 meter. So hectare meter. This is outflow. Right. Now after that, if you will see that we know that the change in storage, or change in storage is what? Change in storage is equal to delta S, and we know that delta S we have taken as a 20 centimeter. 20 centimeter means or minus 20 centimeter, right? Again we will convert it into hectometer. So minus and 20 centimeter is, if I will multiply by 10 to the power minus 2, it will be in meter into, if I will multiply by the area, that is area means what? 1 kilometer square. 1 kilometer square. This is 1. So minus 20 into 10 to the power minus 2 meter into, this is 10 to the power 6 meter square. So it will be converted and we will get it as a minus 2 into 10 to the power 4 meter hectare meter. 10 to the power, sorry, this is minus 20 10 to the power 4 meter cube. So I can say that will it be, is it okay? How much rainfall this is given as? Change in storage is given 20 centimeter. Okay, minus 20. If I will convert it into minus 20, so just I will calculate it. Minus 20 into 10 to the power minus 2 into 10 to the power 6. This is was 20,000. Okay, minus 20 hectare meter. Now we know that inflow minus outflow is equal to change in storage, right? So inflow, we know that that is 10, right? Inflow we have already calculated. Inflow is this, that is 10 hectare-meter and 3 hectare-meter. This is 10 hectare-meter. This one is 10 hectare-meter and this one is 3. And outflow is what, 20 and 8.4, right? So here what we will do, 10 plus 3, right, is equal to minus outflow is what? Outflow is first my is 20, that is plus 8.4, right? That is, just I will check once again. Yes, something is surface outflow is 20, right? Plus okay, I will put the value. So before that, I should write this formula so that it will be more clear to you. Surface inflow, right? Surface inflow plus groundwater inflow, right? Plus precipitation, then minus surface outflow plus groundwater outflow plus some evaporation loss is equal to change in storage, right? Now here it is not given. If it is not given, we will not write. It is not given. This is not given. So we will not write. And surface inflow is how much? Now surface inflow is 10 plus precipitation is how much? 3. So plus 3 minus surface outflow is how much? 20 hectare meter plus evaporation loss is given, not given, right? Now what is another thing is given? Yes, it is given already. Sorry. So 8.4 is given. Now what is given? Plus surface outflow is given. Surface outflow is equal to change in storage is given as how much? Minus 20 hectare meter, right? Just we have calculated this is change in storage, this one, right? Minus 20. So I have written minus 20 plus. What we have to find actually? Determine the seepage loss. Seepage loss. Seepage loss is nothing but this one we can say. So here we will write it. So if I will solve it, so I will write in on another page. 10 plus 3 minus 20 plus 8.4 plus seepage or is equal to minus 20. If we will solve this 13 minus this is how much? 20 plus 28.4 right, plus seepage loss, that is seepage loss is ground outflow, GOF, is equal to -20. If we will solve it, we will get seepage loss, or we can say GOF, right, is equal to 4.6 hectare meter. This is the answer, right? Now next, now there is the evapotranspiration. We have already seen the definition in the first starting. Evapotranspiration means what? Some quantity of water is over the tree, right? So due to what? Due to radiation, this water will go into the atmosphere, and some quantity of water is in the soil, that is also going into the atmosphere. When I will combine these two, this is called as transpiration and this is called as evaporation. So with both phenomena will combine, then that will be called as evapotranspiration. And that evapotranspiration is nothing but that is also called as consumptive use, right? So both are equal, or we can say both are same. Now there are some different methods to calculate the evapotranspiration. So what are these methods? These methods are, see, these methods are what? Direct methods and indirect methods. So lesimeter, this soil moisture studies on plot, and inflow and outflow studies. These are called as the methods to calculate the evapotranspiration. Evapotranspiration. Remember this, evapotranspiration. Transpiration. This method will be called as evapotranspiration. So these are the some direct method, and some indirect methods are also here, and these are given. Blaney-Criddle method and Panman equation. These are what? Indirect method, and these methods are what? These methods are for calculating the evapotranspiration. So we will see it. What is first one? Lesimeter method. So here I will explain this. I think it is better to explain here only. See, what is lesimeter method? We take one, we can say, plant, or in one our this small plant, right? This is the soil, right? Or we say it, what you say, this is the plant, and below that plant we keep some pan, right? We keep some pan, and what happens? Some quantity of water is inserted into the soil. These are what? Soil, right? And these are what? These are the plants. So when we add this quantity of water, so some quantity of water is used by this soil, and through this soil, the plants use this water, and remaining quantity of water is collected into the pan, right? So remaining quantity of water is collected into the pan, and through this method we can calculate the lesimeter. So here what? For example, 1 liter of water is inserted into this into the plant, right? Suppose 1 liter of water is inserted. So what happened? Only 0.5 liter water is used by the soil and plant. So remaining water will come at the pan, right? We will note down that quantity, this quantity. So suppose this is 0.5 liter. So we can say that the remaining 0.5 liter of water is used by this plant. So this is what? This is the lesimeter, is nothing but it is a small tank where we study this evapotranspiration. Now, after that, see, some methods are what they are saying, that is soil moisture studies on plot. Means we make one plot, and over this plot some quantity of water is added, and after that this is some quantity of water is collected. We note down that reading, and remaining reading is what, again we can say that is the soil moisture is used by that the soil moisture used that quantity of water. That is the method. Similarly, this inflow and outflow study is same. Now there is another method that is called as indirect method. Within that, there are the two scientists who given this method, that is Blaney and Penman. This is two methods they given this. So here, what is first Blaney-Criddle method? So he given one equation. Based on that equation, we can solve the problem and we can find out the evapotranspiration. So what is this equation? He given that the consumptive use. What I told you, I have already told you. Cu means what? Consumptive use. Consumptive use. This consumptive use is equal to K into P, K into P into T divided by 40. This formula is when it will be used when this, first of all, I will tell you what is this K, P and T. Then when we use this formula, this K is what? Crop coefficient. Crop coefficient means some of the, suppose in the, this is our, some plant is there, right, within this. So this plant will have some water, will take some water, right? So for different plants they have different coefficient, right? So K is what? Coefficient. T is what? Temperature, and this temperature is in Fahrenheit. Fahrenheit, right? Generally it is represented by F. So when this temperature is in Fahrenheit, then we use this formula. Which one? Cu is equal to K into P into T divided by 40. But when this temperature is in degree centigrade Celsius, when this is in degree Celsius, then we use this formula Kp upon 4 into bracket 1.8 plus 1.8 into T plus 32, where P is what? Percentage of sunshine. Percentage of sunshine. Percentage of sunshine means what? For example, I say that in the one whole year, the total sunshine was say 500 hours. In the whole year, the sun came for 500 years. And I say that in the month of say June, in the month of June or July, the sun came for 30 hours. Sunshine was 30 hours. Means what is the percentage of that month? 30 divided by for whole year 500 multiplied by 100. So we will get this value. What would be that value? 6. So this 6% will be what? This is the percentage of sunshine, right? Or monthly percentage. Like, I think it is clear to you. The same example is given here. The same example, right? Now there is another method. Penman's equation is given, and that equation is what? A into Hn, A into Hn plus Ea, E suffix A into gamma, or you say that is psychometric constant, divided by A plus again psychometric constant. So this psychometric constant is 0.44 mm of mercury per degree Celsius, and Ea is what? Parameter include the wind velocity and saturation deficit. Hn is what? Net radiation in mm of evaporation, means how much. See, suppose this radiation is coming from sun, right? And there is the soil, and within that soil some quantity of water is there. So how much quantity of water is evaporated by this sun, that is measured in terms of mm of Hg, right? That is the meaning. Then A is what? Slope of graph between the saturated vapor pressure versus temperature. We have already seen this saturated vapor pressure and temperature already know. No, some questions are here, just objective type. And one is isoplate. This is one word. What is the definition? The line having the point equal depth of evapotranspiration. Suppose this is the evapotranspiration is having some value. The same value is here. The same value is here. When we will join this value by some line, so this line is called as isoplates. Now, next is the actual. This is some objective question. The ratio of actual evapotranspiration to the potential evapotranspiration is equal to 1. This is, remember, you remember this. If I value A become almost 0, and this value varies from 0 to 1. Now here, is there any other term? No. See, the same thing which we have discussed here, it is given in your uh, PPT or slide. What is field plot method, right? That is in given. What is Penman equation is given here, right? Blaney-Creedle method, the equation is given already. Now, one of the term was remaining, how to measure or how to reduce the evaporation. If you will see, one term was remaining here. The same thing is here. How we can reduce the evaporation? See, why we should reduce the evaporation? Because if we have some reservoir and if sun is there, right, and in the summer season, this is suppose a very huge quantity of water, and in summer season what will happen when sun will be there? So it may be half of the, it may reduce the quantity of water. This sun may reduce the quantity of water. So if this quantity of water will be lost, then obviously the water supply will be disturbed to the people. So we should save this water. So how we can save this water? So first we can say that reduce the surface area. Means if our surface area is like this area is more. So what we can do? We can reduce this area. We can make it more depth, right? The depth will be more. This surface area will reduce, and the evaporation loss will be less, right? This is the meaning. Next is what? Mechanical cover. Mechanical cover means we should apply some cover, but this is only applicable when water body area is very small, right? Then we can apply some cover over the water body, and we can save the water. But it is not, we can say, uh, economical. Now next is the chemical cover. Means if suppose our water body is there, if we sprinkle some chemical over the water body, some chemicals will be here. So what is this chemical? Cetyl alcohol. That chemical formula is this one, C16H33OH, right? That is one of the we can say chemical through which we can find out, we can reduce the evaporation. Another is sterile alcohol, C16 C36 37OH. That is also one of the chemical through which we can reduce the evaporation. Next is we can increase the salinity. Means if it is our water, if we add some salt, if we add some salt in the water body, then water evaporation will be less. But we cannot do this method because this is not good. If we are adding some salt, then what is the use of that water, right? So but it is not feasible, these methods. So here similarly same reasons are given how to reduce the lake evaporation. The same thing is here, less surface area. This is our lake, and this is suppose area. So we should reduce this area, and we should make this depth more. This is the meaning. Next is by growing tall trees nearby the, we can say, reservoir, so that what will happen? Windward side. So by growing all the trees Casuarina on the windward side. Suppose this is water body, wind is coming, so windward side we will make the some trees everywhere so that it will stop this wind, right? And also they can stop the radiation of the sun, and they can save the water quantity, right? Next is what? By spraying some chemicals. I have already told you the name of the chemical. By reducing the temperature, again what they are saying, by allowing the flow of water, temperature is reduced. See, if suppose this river is there and water is continuously flowing, right? So what will happen? This, because of water flowing, so this water temperature will be maintained, and it will not, water will not become hot. Once if it will become hot, then it will evaporate. So we should allow this water to flow so that the temperature will be small, less temperature, and it will not evaporate. By removing the water loving weeds, some of the weeds are over the water, we should remove, and plants like phytophytes and periphery of the reservoir, we should remove this by straightening the stream channel. By the exposed area of the water surface is reduced and hence evaporation is reduced, right? By providing chemical covers, by developing underground reservoirs. So they are saying that we should, suppose this is our surface, right? And some reservoirs are here. So we should construct some underground water, and we should store this water into underground so that we can save this evaporation loss, right? By developing some underground reservoirs. Next is what? If the reservoir is surrounded by huge trees, thus or forest, the evaporation loss will be less. The same thing, because the temperature will be less. So these are some reasons we have discussed earlier, right? Now here I stop this because already I think it is clear to you. Now one more term, one thing was remaining. This one. See, we have seen this already. See, this pan evaporation is given for different months and coefficient is given. See, we know that lake evaporation is equal to pan coefficient multiplied by pan evaporation. So pan evaporation is given, pan coefficient is given 0.75. So if you will multiply it by 0.75, you will get the evaporation or the lake evaporation, right? So you will get the lake evaporation, right? Likewise, you will multiply it by each reading, each value by 0.7, you will get this. This is actually here already given. Now, next is some empirical equations are given. That is what? That is Dalton equation. He is saying that evaporation loss is K into FU into EW minus EA. This is, we have already seen, saturated vapor pressure and actual vapor pressure in mm of mercury, and FU is what? Wind speed correction function, and K is what? A coefficient, right? And EA term at the same height at which wind speed is measured, right? So EA is measured at the same height at which the wind is, where the wind is flowing at the same height, at the same side. What is the height? We will measure that. Similarly, some other empirical formulas are given. That is mere formula 1915, Km into EW minus EA into 1 plus UG divided by 16, where UG is what? mean monthly wind is velocity U9 actually. This is the velocity. Suppose this is our ground. So up, about 9 meter, what is the velocity of wind? What is the wind velocity? We generally represent it by U9, means velocity in about the 9 meter. Km is what? That is the coefficient of 0.36 for large deep water and 0.5 for small shallow water, right? This is Km. EWEA we know that is already, right? E and U9 is monthly mean velocity, that is already given in kilometer per hour. This is what? In kilometer per hour. See, this is in kilometer per hour, that is velocity. Km is the coefficient and that value is 0.36 and 0.5 depends on the height, right? Next, EW and EA is what? That is the vapor pressure in terms of mm of Hg, right? Mm of Hg. So here some problem is given. See, simply just reservoir is given, its area is given 7 to 50 hectare, and the values, temperature is given, relative humidity is given, wind velocity 1 meter above the ground is given, surface that is 16 kilometer per hour. Estimate the average daily evaporation from the lake by using Mears formula. Second is an ISI standard evaporation pan is given, coefficient is 0.8 given, evaporation is given as 72 mm in the week under quest. Now what we have to find? Estimate the accuracy of Mears formula and also estimate the volume of water evaporated from the lake. So here, see, this is mm of Hg is given, EA, EW value given, wind velocity U19, that is the formula U1 into, see, this formula is applied and we got it in kilometer per hour using this equation. That is what equation? Mears equation. So we will put all the values 0.36 because it is below 9 meter. That's why 0.36. Then 17.54 is this. EW minus EA, that is 7.02. 1 plus U9 means 21 point, this one, 9 kilometer per hour divided by this 16. So we will get this mm per day. Similarly, daily evaporation from pan, we will find this 72 mm. What is that given? Just I will check. Sorry. In a week, that's why it is divided by 7, right? In a week is given. If it is in a month is, then divide by 30. So 72 divided by 7 multiplied by pan coefficient will get the evaporation from lake, right? Now we will apply the error by Mears formula is what? Whatever the value we got from here, and we will take the difference of these two, we will get the error. Then if we will divide it by 8.23, that is what we got from the pan value. So we will get the 9% error in the pan, right? Now, what would be the value from the leg in 7 days? We know this is this value is daily evaporation. That is 1 day evaporation is 8.27, right? So if we will multiply it, we will convert it into a meter and multiplied by 7 days, we will get in 7 days evaporation. Then multiplied by area. Area means area of the reservoir. I think this area is given 250. How much it is? Yes, 250 hectares are given. So if we will multiply the area, we will get the quantity of water, right? We know that the formula for volume is equal to what? Volume is equal to depth multiplied by the area. So depth for 7 days is converted here, this one, and area is hectare meter. So we got that is 10 to the power 4 is what? Meter square. 10 to the power 4 meter square is equal to what? 1 hectare, right? And remaining one is in meter. This one is in meter. So when this will multiplied by whatever the value is here in meter, this is also in meter square, we will get in meter cube. So that's why we got this answer. See, Mears formula 1945 is also given. Lake evaporation in inches per day, that is C into ES minus E, 1 plus W divided by 10. So ES minus E is water deficit, water vapor deficit. E is what? Lake evaporation in inches per day. C is what? Constant, 0.36 for open water and 0.5 for wet soil. W is the wind speed, 25 foot above the water level in mile per hour. So here I hope that everything is clear to you. Now, almost I covered all the evaporation chapter. So I hope you will get, uh, you got this. And if you have any doubt, you can ask. So here I stop. And your syllabus is what? Evaporation, runoff and hydrograph, and the last one is flood.